Another one of the old limit problems, number 58, take the limit as x goes to negative infinity, and then this is a product. And if you have x go to infinity, x squared means negative infinity squared, which is going to be positive infinity. And then if x is going to negative infinity, this exponent is going to become negative infinity. Now, e to the positive infinity is positive infinity, but with a negative exponent, that means invert it, so it's 1 divided by infinity, which goes to 0. And then we've got a slight problem. One problem is, when you're talking about limits, when you have it of the form infinity times 0, it could end up being anything. The answer could be 0, 12, negative 19, so we need some other work. The other small problem is, in order to use L'Hopital's rule, it has to be 0 divided by 0 or infinity divided by infinity. This doesn't even have divided. So the first thing I need to do is rewrite it so that it's something divided by something else. So what I could do is leave the x squared there and then put e to the negative x in the denominator. So e to the negative x in the denominator is the same thing as e to the x in the numerator. Now, if you let x become negative infinity, this, once you square it, will become infinity. Because of the negative exponent, that means it's 1 over, or actually another way to look at it is, an easier way to look at it is, if you put the negative infinity for x, the two negatives will cancel. So it's going to be e to the infinity. So that means the top is infinity and the bottom is infinity. So now we could use L'Hopital's rule. So take the derivative of each one. The derivative of the numerator, that's going to be 2x. The derivative of the e function is the e function. And then you need to do the chain rule. The derivative of a negative x is negative 1. And then this would still be of the form infinity over infinity, so do L'Hopital's rule again. The derivative of the top is a 2x. And the derivative of the bottom, well, you would repeat the process. The derivative of the e function is the e function. And then the chain rule. So the derivative of this would be a negative 1. When you multiply it with this, the two negatives are going to cancel. So we get just this. Then, now that this is just a constant 2, if you substitute the negative infinity in here, the two negatives will cancel. So that'll leave e to the infinity. And e to the infinity is infinity. So it becomes 2 divided by infinity, which is equal to 0. And then I just want to graph it and see if that looks correct. So the original problem, the way it was originally stated, x squared times e to the x, and then x is going to negative infinity. So I need the x-axis to go out towards negative infinity like this. And I believe that the answer is 0, so I could change the y-scale to -1 to +1. And then take a look at the left side of the graph. So right here's the y-axis, there's -1, -2, etc. And as you can see, the function has this little blip right here, but then it's practically 0. And then if you trace, it says if you're out here at -49.5, the y value is 0. So this one is correct.